Hello, everyone, and welcome to CircuitPython Day 2025. We have a very special session right now with community member Sophy Wong. Hello.
Hello.
Hey, and so you're going to be talking to us today about how you've used CircuitPython in some of your props, specifically a really cool, awesome spacesuit that was used in a film.
Yeah, so I made a spacesuit, an original design spacesuit for someone who was making a little independent short film. And when I say little independent short film, it's like so much bigger than anything that I've ever worked on before. Like a real person was wearing this spacesuit for multiple sessions of recording in the field over the course of a year. So it had to be pretty robust, and he had some really specific like design requirements. We needed to have a bunch of lighting in it and electronics in it. So it was the perfect application for a bunch of cool Adafruit products and of course CircuitPython that I used to make it all work. So today I wanted to show specifically the helmet, and I'll grab it.
Okay.
It's here.
Wow.
So it's quite large,
Yes,
and
donkey.
it is totally custom. So this is something that I 3D modeled mostly in Fusion 360. And then I added a lot of foam pieces to it to really get a lot of depth and detail. I've got two headlamps up here that just illuminate the area in front of the person as they're walking, and they become these giant point lights on the top of the helmet.
Nice.
And then inside the helmet, I have NeoPixels, of course,
Yes.
two strips, one at the top there, and then one at the bottom down here that they both kind of just illuminate the face. And then I have these side lights that are NeoPixel, the little sticks.
Okay. Yeah.
And those are covered by a little vacuum formed diffuser that I made.
Very
So
cool.
that's a little custom shape too. And then at the back, I have these two knobs that are actually controls for the color of the NeoPixels. And then this is the on-off switch here. Inside this compartment is all the electronics and a rechargeable battery. And when I flip that switch, the lights come on. And yeah, so basically these two knobs can change the color of these outside lights and the inside lights, because the director wanted to be able to change the color depending on the scene.
Okay.
I wanted to do some really cool creative applications of color where, like, if he had a really red cast on the inside on the actor's face, you could tweak the color in post so that that person looked normal inside, but everything else looked really trippy.
Oh, you know? Very cool.
Yeah, he's a colorist in addition to being a director. So he had like really cool color things he wanted to do. So I needed to give him color control. So basically, if you turn the knobs, and I can't remember which one. Oh yeah, there we go. So if you turn the knobs real time, you can just dial in like whatever color you want that to be.
Okay, very cool.
And then on the inside, we did, in the code, I have it starting at white. And then turning the knob will change. Wait a minute, wrong knob. Turning the knob will then start to cycle through the color wheel.
Oh, very cool. Yeah.
So he has a little white, just like neutral white option in there too. So that's the overview of the helmet electronics. The whole thing is completely contained, so it doesn't tether to the rest of the suit. It just like slots into the neck ring. And I wanted to just make sure that if anything happened, if he absolutely needed to get out of this suit, he could just rip the helmet off his head, and he didn't have to deal with any like wires plugging in or anything like that. So it's a totally self-contained.
And that's an important design consideration then you had to think about, as far as then how that would affect the electronics and how that would affect everything, really, that you're going to have these kind of two modular parts that are coming together.
Yeah, exactly. So we have electronics in the suit as well. I have some lighting in there. I have fans in the suit part, and that's a whole separate circuit with its own board running completely separately from the helmet. And I think it's just easier for clients. It's like this director and this actor and everyone on set, they have so many other things that they need to think about and prioritize. And I knew I wasn't going to be able to be there on set to actually like be the handler for the suit. So I had to build it in a way that it just worked for them and it was dependable.
Yeah.
And the feedback I got was that it did that. It totally performed, and it didn't. All they had to know was how to recharge it, how to put it away when they were done, and how to turn it on when they wanted to film again.
That's great.
So, yeah, there were a couple of things that we wanted to adjust. As they started shooting, they realized like, oh, we want to change this color a little bit, or we want to change this. I can't remember exactly what the functionality was, but after their first day of shooting, they wanted to just make a couple of adjustments to the behavior. And so it was really easy for me to do that because with CircuitPython, I could just, I have my own prototype here that I could tweak the code on, get it working, make sure that it works, and then just send them a file that they could just drag and drop onto the board in the helmet. And it just, updates for them. They don't need to know anything more complicated than that to make that change.
Nice.
So I just love that they could just plug it in and it just shows up like a drive.
Yeah, you're not having to deal with like compiling and making sure that, they have a test bed too. Like you can just do it on your own, give it to them.
Yeah. Yeah. And then even if I did have to have them go in and like change something, just knowing that they could do that in a text editor and it would, they could just navigate it like a regular document is just so much easier than literally any other way to do it,
Yeah. That's great.
Yeah, it's worked out really well in that project. So I'm making some more. So I got, another helmet back here that I'm working on. And my next ideas of what I want to do is I kind of want to start from where I ended on this one and kind of build out a whole system for suits like this.
Very cool.
I'm going to make kind of different models and try to make them sort of modular. And this one was really specific. Like I built it really specifically for his character and his story and his films. And now I want to make some that are a little more open to interpretation so they can be used for different projects or different films or music videos, and maybe with just a little bit of changes, they can be reused, and basically build myself a little fleet of usable spacesuits that have similar functionality to this one.
Very cool. And you have kind of the test bed that you use with the board and everything.
Yeah. So this is in this one I'm using an Itsy Bitsy RP 2040.
Yeah.
And I have got, when I start working on these projects, I have a little prototyping kit that I keep. All of my little components that I use regularly, or I've used them in the past, like if I built out a little prototype in the past and then I ended up rebuilding it for the project, I save the prototyping that I did and all the components, the little, test components.
Yeah.
I even have like some that I've put connectors on so that I can really quickly like throw together another prototype. And because the boards keep the code on them like a drive, I can just plug them right in and start kind of noodling on what I've already got in there. I try to keep notes in my code so I know what it does and what I need to change. And it's just my little, it's just really handy for not having to start over from zero every time I'm making a new thing. Oh, and one thing that I'm really happy that I figured out and that is still in my prototyping box is this, which is it's a cutie pie stemma connected to the I2C memory
Okay.
EPROM. And that was really, really useful. I figured out how to use this with your help, Liz,
Oh yeah.
on this helmet and the suit. I think I'm using it on both the helmet and the suit part in this project because I knew that the director was going to want to set his colors and then have them stay consistent throughout turning the suit off and turning it back on again. So they knew they were going to shoot over the course of a year, and they were going to shoot, maybe it might be like a couple of weeks to a month between shooting because they wanted to get these different times of year. And so I knew that he was not going to want to have the suit reset every time he turned it off and turn it back on again, because you need continuity when you're shooting a film. So I was like, I got to figure out a way to store the color values and the lighting values so that every time he turns it on, it's exactly where it was when he turned it off. And the EPROM let me do that in a pretty simple way. And I love that functionality. So I'm definitely going to build it into the newer ones too.
Yeah, I think when we were chatting about that, I may have just written the product guide for that breakout. So it was kind of fresh in my mind, like, oh, I bet you could use this. And I think that's a common thing that folks want to do, especially with CircuitPython, is have it remember a value. And the one thing with CircuitPython is even though it's a USB drive, you can't really write to it while you're using it. USB devices won't allow you to do that. And we have a session earlier today with Scott and Dan where they were kind of talking about that and the different saves partitions that they're kind of putting in with the new version. And so the EPROM gives you a way to do that in code. So if you have a value that you want to save and recall on boot, you can do that without messing with the USB drive. I actually also use it in my husband and I have a chess scoreboard. And we use Adafruit.io to log when we win a game, but to keep the scores over time, Adafruit.io will get rid of them after like 3 months, I think. I use EPROM to write the score so that we never lose who's winning.
That's so, it's really important. You never
know. Much to my disadvantage right now, I'm behind.
Whoops! Did I reset that?
So the EPROM breakout definitely handy if folks want to try doing stuff like that.
For sure. And I like that there's also the option of like storing data. Like you can send it to a web page, or you can log in other ways. But if you're shooting a film out in a field and you might not even have service, you don't want to. I didn't want them to have to deal with like connecting anything or logging into anything, like just to be able to store it in the actual object is so useful in an application like this, and still keep it really, really small. I don't have to graduate to something, more robust like a Raspberry Pi or something that's more like a full-on computer. Like you can still keep it so incredibly tiny and then just like fit it in my suit wherever I can,
Yeah, I feel like as projects get more complicated, almost the mission becomes like, how do I not make this a Raspberry Pi project? No shade to Raspberry Pi obviously has its place, but
for sure,
with the portable things, you kind of are like, okay, how can I achieve this?
And it's got to be portable, and it's also got to be usable by someone who's totally uninitiated to all of this stuff. And I just didn't want to give something complex like a Raspberry Pi level, like computer brain type of thing to people who are, they could manage that if they wanted to, but they've got so much else to deal with, like they want to make just to say, like the person wearing this suit is like covered. It's hot. It's, you don't have great visibility, and you're trying to act, and you're trying to like tell a story, and you're trying not to fall on your face. He was running through like they had him shooting out in nature, like in Nashville. So it's like humid, it's super hot, it's beautiful greenery, forest. There's this one shot where they released a bunch of butterflies around him, and there's like this beautiful shot of him in the suit. The lights are on, and there's a butterfly like right here.
Oh, nice.
And it's like, doing the like wing thing. You know, like they're trying to capture these moments and the suit just has to work without them, you know, worrying about anything. Like if it had glitched out at that moment, you know, that would have been disastrous.
Yeah.
So the simpler, the better, the fewer things that can go wrong, the more solid, you know, you can make it, the better chance you have of it just like performing.
And that speaks to your design too, because I think you said when you got back you had like pieces of grass in it and stuff, and everything held up for them.
Yeah.
Very
And
good.
I was worried about that because this is the most like, you know, demanding situation I've put a suit like this in. And I'm really surprised when it came back. I was like, whoa, it looks the same. It came back okay. They did take really good care of it, but they also like used it as they needed to and made this film. So yeah, I'm pretty happy.
And I do want to mention, because you said you have a parts tray, I have a similar box that I keep on my desk.
Yes.
Because I'm writing the product guides and everything. There's if you look in our boards guides, you'll see like the same sensors are kind of used for the demo thing. So I have them all here so that I can just grab them very easily.
Good.
So if you are an avid maker, that's definitely a hot tip. Your most used parts, keep them separated from your main part storage, so they're right on your desk.
Yeah, so easy to just whip it together, get it going.
Yeah,
love that.
Yeah. So I know you said there's knobs on the helmet. Can you talk a little bit about those, like the hardware used for them?
Yeah, so I use the Stemma rotary encoders. And so it's just part of my I2C like chain coming out of the Itsy Bitsy. And here it's Itsy Bitsy. On my prototype board, I have a cutie pie, but it's basically all in the chain. So I have the EPROM and then 2 of the encoders connected together. And, you know, I'm just using the little, what do you call them? The little
Stemma QT cables?
Oh yeah, the cables, but the little, you know, the little pins where you assign the address.
The address jumpers.
The jumpers. Yeah. I'm like, what is that word?
Right.
Yeah, so I'm just using the jumpers to assign them their addresses, and so it's just a little chain of 2 of these encoders and then the EPROM, and that's all I'm plugging in. And just having them be like plug and play like that is also really not just making it easy for me to build my circuit, but if anything were to happen and they had to like replace that, they could unplug it and, you know, stick it. I could send them a new one and they could just stick it in. So I'm kind of using that functionality and that concept of everything being plug-inable for other parts of the suit too. So in the suit, the rest of the suit, I have fans. My fans are like these like PC style fans. Okay, and I do them all with connectors so that if the fan breaks, and the fan's going to be running 100% of the time when someone's wearing the suit. So it's high likelihood that they're going to, you know, get fatigued and get broken. And, you know, if he falls or if he bumps into something, like fans just break. So I had to make sure that they be able to replace the fans really easily. So I do all of them with little connectors. And I gave them a bunch of extra ones with Velcro. They're not glued in or screwed in. They're just Velcroed on the underneath a panel in the back of the suit. And I sent them extra ones with Velcro on them. So if they had to replace a fan, they could just unplug it, rip it out, stick a new one in, plug it in, and then they're good to go. So I love that, like, just the idea of everything just being plug-inable. And then this is not a coding thing, but do you know about these like connectors, these heat shrink connector things?
I don't actually, I don't think.
So, okay. You know how, so, and I found these through doing a workshop, and I was looking for a way to get people to connect things without having to solder. But what I found is like, they're so great for when you have to solder one wire to another wire. You know how when you do that, it's a pain in the butt because you have to strip both sides, stick them together, solder it, and then whoops, you forgot to put the heat shrink on it. So we have to cut it apart again and then start all over and then like put the heat shrink on and do it. So this is a little thing that is the heat shrink and the solder combined.
Oh.
So all you have to do is strip your wires, stick them in so that they meet right where the solder is in the middle.
Yeah.
And then when you heat it with a heat gun, it cinches it all in and it melts the solder at the same time.
That's
so
amazing.
You get this. You basically get 2 wires connected.
That's so cool. I've never seen that before.
Isn't it amazing?
Yeah, that's very cool. You'll link me to that.
I mean, I don't. So you have to buy them in gigantic
That's fine.
amounts.
Nice use of a 20 jar, by the way.
Oh, don't eat them. But yeah, this is the best gelato ever. But basically, like, I never want to go back to just the manual way of like soldering a wire to a wire is like the best use case for this. It's just like 30 seconds and you're done.
That's so
and
good.
you can't forget the heat shrink because it's built in.
Right.
You know.
Oh, that's so good. And then where you talk about the fans, I know you've said that you found a lot of useful information from fans about fans in places. You want to talk a little bit about that?
Oh yeah. So the fans that I use are these like PC fans, and they also appear on like 3D printers. But how I kind of got to this as my fan is I wanted to do research and figure out what is the best option for fans, because I also was looking at fans like these, which are blower fans. You know, they blow in a direction,
right,
as opposed to open fans that just blow out from the side. And so I had to like learn about fans, and the place that I always go when I need to learn about what's the best way to cool someone down inside a suit is the fursuit forums.
Yes.
So the furries are the fan experts.
Yes.
They know because it is hot in those suits, and they wear them for long periods of time, and they're active in them at their cons, you know. So and they talk about it a lot, and they're very they are really clever about integrating their fans into their suits, and they have a lot of experience in what works and what doesn't work. So I learned a lot from kind of going over their forum posts and seeing how they put things together. And really what I learned from them is that they're balancing the same way that I want to balance the same things in my suit, which is you want cooling, but you also are looking for the quietest option,
right,
because it's blowing right into your personal space. It gets very loud. And if it's going to be on for a long time, that's a lot of noise and vibration that you're experiencing inside. So my takeaway from all my research on that is the option that people seem to like the best is a 12-volt fan running at 9 volts, running on 9 volts. So you're intentionally underpowering it a little bit, and that gives you enough air movement, enough powerful air movement with minimal noise. The fan is just quieter when you're not running it at maximum. And then the other thing is you have to have exhaust. You have to have ventilation. It's not just about moving hot air around inside.
Yeah.
You got to have a place for the air to come in and go out. So I always try to build some kind of holes that are not super visible, because I'm also dealing with light going on inside of the inner compartment. And so if I have any holes that will show that light, it's really obvious that there's a hole in the helmet, and you're trying to create this illusion of like, you know, you're in space and you can't be exposed to the outside.
Yeah.
So I'm coming up with clever ways to kind of cover those holes and shield them. So I'm working on, you know, this kind of addition to my helmet where I'm kind of improving the flow. This suit did pretty well in terms of ventilation and heat control and keeping the humidity down, because if you have hot, humid air in here, which is coming out of your mouth because you're exhaling, the whole inside of your visor will just fog up.
Right.
And no amount of anti-fog coating is going to handle that. It's
Yeah.
just, you know, you have to vacate the air. You have to let it out. So, so I'm adding some more holes to the helmet, inlet and exhaust holes, and I'm beefing up my fans. And yeah, I think this new helmet, this whole suit is going to be an improvement on this one because I learned so much from actually deploying it, you know,
Right. Yeah.
with someone.
Yeah.
So that's where I'm going with the fans.
I love it. And I think it also shows, like, you know, there's all these like specialized pieces of information for different communities in like the maker space, whether it's, you know, cosplay or the furry community or you know, our own Erin St. Blaine does a lot with like mermaid things. So there's all these different corners that have different pieces of expertise. So when you're researching a project that maybe are touching on areas that you don't have a lot of experience in or you want to learn more about, like definitely maybe look beyond like your immediate bases just to find these nuggets of information.
Totally, totally. I mean, there's also like one just shout out to the furries. Like they're so clever about it.
Yeah.
They do things like they're all hot. Like everyone's hot in their suit. And they will take, you know, those personal fans that you can buy on Amazon. They like look like a little rectangle like that, and they're basically a blower fan. And you can like put it on your pocket and like blow, you know, air on you when you're walking around in the heat.
Yeah.
They will take those fans and they'll build them into a prop so they can hold the fan. So yeah. A really common one that they do that's so cute is like they want to put the fan in the mouth of their suit because that's where they get their airflow, right? And their face is right there. So they'll build a little housing for that fan that looks like a popsicle, like a giant popsicle.
Oh, that's cool.
So they put the popsicle in the mouth and it's the fan blowing air in, but it doesn't break the illusion of, you know, the cute animal, like you know, just eating a popsicle. Like it's so clever, like disguising something like that. So definitely like looking at other places where people are doing similar things with a similar, you know, technology, but applying it in their way is so helpful for design, you know, for like thinking outside of the box and just like getting a new take on something or considering something that you didn't even think was an option. Yeah, for sure.
And speaking about learning, where can folks go to learn more about what you're up to?
Oh, well, on my website, sophiewong.com, I've got my projects on there and I started a blog that I really need to update. But yeah, that's where I'm going to be posting all of my projects and new things to come, like when I'm getting a little bit more developed on these suits and maybe some, you know, workshops and learning opportunities and stuff like that.
Excellent. Well, always great to see what you're working on. Your work is amazing, and even double bonus for us that it's using CircuitPython. And thank you for chatting with us today. I think it's a great way to see all the ways people are using CircuitPython in ways that you may not expect. So thank you.
Well, thanks for having me, Liz. Always awesome to be here. Thank you.
No problem. Have a good one. And stay tuned, folks, for more CircuitPython Day content.